This is your telescope, an engineering marvel, an exploration powerhouse. Use it to look back in time and explore the first galaxies that formed after the Big Bang. To peer into atmospheres of planets orbiting the stars. It's your eyepiece to the uncharted, unknown, and unimagined. This is the largest, most complex, and challenging space telescope ever constructed. It will change our understanding of the universe and our place in it. The James Webb Space Telescope.
Einstein's theories have shaped our view of the universe for over a century. But what if everything we thought we knew is about to change? The James Webb Space Telescope is sending back discoveries so wild they're shaking the very foundation of physics. Galaxies that shouldn't exist, cosmic mysteries that defy logic, JWST is rewriting the rules. Are we witnessing the moment Einstein's legacy gets scattered? Get ready, because the universe just got a whole lot stranger. The universe just broke every rule. We thought we knew.
Supermassive black holes might be tricking us into thinking some early galaxies are more massive than they really are. When the James Webb Space Telescope first observed galaxies in the early universe, astronomers were surprised by how bright and large they appeared, way more massive than our theories predicted. It sparked what was called a crisis in cosmology, making us question how the universe formed and evolved after the Big Bang. But here's the twist. It turns out that much of the light from these galaxies wasn't coming from stars, but from supermassive black holes at their centers. As these black holes devour gas, they produce intense light, making the galaxies appear much bigger than they are. Once scientists accounted for this, it restored confidence in our current understanding of the universe. But that's not all. Webb's observations also revealed that galaxies in the early universe were incredibly efficient at forming stars, more so than we expected. This tells us that conditions back then were perfect for rapid star formation. To learn more about this new study, watch our full YouTube video and see you there.
Something absolutely mind-blowing is happening in space right now, and it's making the smartest scientists on Earth question everything they thought they understood about our universe. The James Webb Space Telescope has been sending back data that's so weird and unexpected that researchers are starting to wonder if we've been fundamentally wrong about the most basic facts of reality. These aren't small adjustments to existing theories. We're talking about discoveries that could completely flip our understanding of the cosmos upside down. Andre Kutow from the Lawrence Berkeley National Laboratory recently said something that should make everyone pay attention. He explained that scientists are in the business of letting the universe tell them how it works. And right now, the universe seems to be screaming that things are way more complicated than anyone ever imagined. The discoveries coming from Webb are so strange that many respected researchers are seriously asking whether we might be standing on the edge of a breakthrough that changes absolutely everything we know about space, time, and reality itself. Ancient galaxies that shouldn't exist.
A spiral containing multiple arms at the redshift of 3. This is when the universe was about 2.3 billion years old. Just a little bit closer compared to the Big Wheel galaxy, which of course implied that spirals could definitely exist early on and potentially formed through mechanisms we just didn't understand. And then we have the record holder, a galaxy analyzed in 2021 and confirmed to be the farthest spiral ever seen. The light from this galaxy took 12.4 billion years to reach us, and the universe was only 1.4 billion years old. And the galaxy where once again the spiral arms are quite visible. But here this was observed with ALMA, using microwave frequencies.
The first shocking discovery hit when scientists analyzed thousands of early galaxies that Webb had spotted in the deep cosmos. What they found was a cosmic monster they named the Big Wheel. And this galaxy completely destroys every rule about how galaxies are supposed to form and grow. The light from this giant has been traveling for over 12 billion years to reach us, which means we're seeing it as it existed when the universe was just 15% of its current age. This discovery is absolutely earth-shattering. Because everything we thought we knew about galaxy formation says this should be impossible. Early galaxies are supposed to be small, chaotic, and barely held together. They should look like cosmic babies, still figuring out how to exist in the universe. Instead, the Big Wheel looks like a fully mature galaxy that rivals the largest spiral galaxies we see today. It's 3 times bigger than other galaxies from that same era and ranks among the most massive galaxies ever observed in the early cosmos. The big wheel isn't alone in breaking these fundamental rules. Webb has discovered multiple massive, perfectly organized galaxies from this early period, and every single one challenges our standard model of how the universe evolved. These galaxies are so advanced and well-structured that they appear to have grown up impossibly fast. Our current understanding says galaxies need billions of years to slowly accumulate matter, form stars, and develop their beautiful shapes. But these early galaxies seem to have completely skipped the slow developmental process that should have taken eons. Dark energy started acting.
Space Telescope has captured images of ancient galaxies that are far larger and brighter than expected, challenging our traditional view of dark matter. This surprising find has reignited interest in an alternative theory called modified Newtonian dynamics, or MOND, which offers a new perspective on gravity's role in shaping galaxies.
Weird? Just when scientists thought massive early galaxies were bizarre enough, Webb uncovered something even more disturbing about dark energy: the mysterious force that drives the expansion of our universe. This invisible power, which scientists have assumed stays constant throughout space and time, might actually be changing in ways that completely wreck our understanding of how the cosmos works. The original discovery of dark energy back in 1998 was already a massive shock to the scientific community. Before that breakthrough, everyone assumed the universe's expansion was slowing down because gravity was pulling everything back together. But observations revealed that the expansion was actually speeding up, powered by some unknown force that scientists couldn't identify or explain. They named it dark energy simply because they had absolutely no idea what it was. Now, more than 25 years later, new data from Webb and other instruments suggest that dark energy might not be the steady, predictable force that scientists built their theories around. Instead, it appears to be behaving in ways that are much stranger and more unpredictable than anyone expected. The Dark Energy Spectroscopic Instrument has been gathering data for over a year, and the results keep pointing to the same troubling conclusion. Dark energy is changing over time in ways that our models never predicted. The universe can't agree on its expansion rate. Webb's observations have also made it impossible to ignore a major problem that's been bothering scientists for years. It's called the Hubble tension, and it describes a really frustrating reality. Different methods of measuring how fast the universe is expanding give completely different answers. When scientists study the cosmic microwave background radiation, the leftover glow from the Big Bang, they calculate one expansion rate. But when they use direct observations of stars and galaxies, they get a totally different number. This isn't a small disagreement that can be brushed aside. The difference between these measurements is so large that it suggests something fundamental is broken in our understanding of the universe. It's like having two different speedometers in the same car that consistently give you completely different readings. Nobel laureate Adam Riess, who has dedicated years to studying this problem, has found that Webb's incredibly precise observations make the tension even more obvious and harder to explain away. The Hubble tension is particularly maddening because it affects the most basic questions about our universe. If we can't accurately measure how fast space itself is expanding, how can we be confident about the universe's age? How can we understand its history or make reliable predictions about its future? The fact that different measurement techniques give contradictory results strongly suggests that there's some fundamental physics happening that we haven't discovered yet. Time itself might be playing tricks on us.
But in 2007, David Wiltshire, a theoretical physicist from New Zealand, proposed something slightly different. He basically named his model Timescape Cosmology. Honestly, a pretty cool name. And so in his model, he basically suggests that the universe is not as smooth and as homogeneous as we believe, or basically the bread is not really smooth and not flat, but is instead super clumpy. It has certain regions that are way more clumpy than other regions, and other regions that are very empty and potentially expand really fast. But the reason his model is called Timescape Cosmology is actually because he believes that in certain regions in the universe, the time basically runs at different speed. Or in other words, time tends to run slowly In locations with a lot of density and basically a lot of dark matter.
One of the most mind-bending theories that scientists are now taking seriously is called timescape cosmology. And it suggests that everything we think we know about cosmic expansion might be a massive illusion. According to this radical idea, the expansion of the universe isn't driven by mysterious dark energy at all. Instead, what we're observing is the result of time itself, flowing at different speeds in different parts of space. The theory proposes that time moves slower in regions packed with matter, like inside galaxies, and flows much faster in the vast, empty regions called cosmic voids that exist between galaxies. Imagine an atomic clock sitting inside our Milky Way galaxy, ticking up to a third slower than an identical clock floating in the middle of a completely empty void. Over the billions of years that the universe has existed, this difference in the flow of time adds up to something absolutely incredible. In cosmic voids, where time has been racing along faster, billions of additional years may have passed compared to the matter-rich regions where galaxies live and evolve. This means the universe doesn't have a single, uniform age like everyone always assumed. Instead, the age of the universe varies dramatically depending on your location. Since more time has passed in these voids, they've experienced much more cosmological expansion. When we observe objects on the far side of a void, they appear to be racing away from us much faster, creating the illusion that the overall expansion is accelerating. Everything spins in perfect harmony. Webb has revealed another mystery that's making scientists question the very foundations of how the universe began. When researchers analyzed 30,000 galaxies captured by the telescope, they discovered something that should be impossible according to our understanding of the Big Bang. Most of these galaxies are rotating in the same direction, which is incredibly strange given what we know about how the early universe should have behaved. According to the Big Bang Theory, the early universe was a completely chaotic environment, with matter and energy flying in all directions randomly. When galaxies eventually formed from this cosmic chaos, they should have ended up spinning in completely random directions. Some should rotate clockwise, others counterclockwise, with no discernible pattern across the vast cosmos. But Webb's observations show exactly the opposite of what the theory predicts. This unexpected uniformity suggests that the universe might have started with some kind of initial rotation or spin that current theories don't account for. It's like discovering that every single planet in our solar system rotates in perfect harmony when they should all be spinning randomly. The discovery raises profound questions about what really happened during the Big Bang, and whether we're missing some fundamental aspect of how the universe came into existence. We might be living inside a giant black hole. The most absolutely mind-blowing theory that some scientists are now seriously considering is that our entire universe might actually exist inside a massive rotating black hole. This idea, known as the black hole universe hypothesis, sounds like pure science fiction, but the recent discoveries from Webb are making it seem more realistic than ever before. The theory suggests that what we call the Big Bang might have actually been the formation of a colossal black hole, and everything we see around us exists within this cosmic black hole. If this black hole is spinning, it could explain why galaxies tend to rotate in the same direction, and why the universe displays certain patterns that the standard Big Bang model struggles to explain. This concept is based on real physics that describes what might happen inside the event horizon of a black hole. While we know that nothing can escape from a black hole once it crosses that boundary, what happens inside remains largely mysterious. Some theoretical physicists have suggested that the interior of a black hole could contain an entire universe with its own unique physics that operate completely differently from what we experience. If we really are living inside a rotating black hole, it would solve several mysteries that Webb has uncovered. The uniform rotation of distant galaxies would make perfect sense if they're all influenced by the overall spin of the black hole that contains our universe. The strange behavior of dark energy could be explained by the exotic physics that exist inside such extreme gravitational environments. Even the impossibly rapid formation of massive early galaxies could be understood if the conditions inside a black hole allow for accelerated cosmic evolution that defies everything we thought we knew about how the universe works.